In this video, we are going to continue our discussion of 2.6 part 1 over homogeneous polar DEs. I am going to show you, we're going to use the same exact problem from the last video, example 4, and I'm going to do one little thing different, show you that it shows the same, and that'll be it. So last time, we already showed that this was homogeneous polar. I don't need to do that again. We're not going to do that again. But instead, what we're going to do is start with this same substitution, but we're going to think about our derivative as differentials instead of derivatives. So this is dy equals, I take the derivative of x, I get dx. I take the derivative of v, I get dv. So we get that substitution. How this works is this keeps me from having to go to the other form. I can actually take this now, multiply, put everything in 4x squared, x times vx plus vx squared times dx minus x squared, and then we replace dy. We know what dy is. All right, I'm going to do these multiplications. We get 4x squared plus vx squared plus v squared x squared, right, dx minus x squared v dx minus x to the third dv, and this equals 0. I forgot to finish the equation right there. Now I can combine my dx's together. So notice a couple things in there. We have vx squared. That's going to cancel with that vx squared. So we get 4x squared plus v squared x squared dx minus x to the third dv. And now we can start trying to solve that. We could add the x to the third to the other side, 4x squared plus v squared x squared. Let's go ahead and factor that square out, actually. So x squared times 4 plus v squared. You can start seeing the same things that we had in the other problem. And we got x to the third dv. Now, this is separable. I divide by x cubed. I get 1 over x dx. I divide by the 1 over 4 plus v squared dv. And then this is the last example. So example 4, I guess I should write that. Always looking for abbreviations. Example 4. Okay, so that's how you solve that. We have two different ways. Either route, it really doesn't matter. You have to manipulate one to get to the other and vice versa. So it's really the same thing.